Hi everyone, in today's video I'm going to walk you through some graphing exponential functions. A big thanks to Delta Math for letting me use their questions. So the first question here on the screen says use technology to find the points and then graph the function y equals 1/2 in parentheses x minus 5 minus 1. So when you're asked to graph an exponential function, just use your graphing calculator. Hit the y equals screen and type in the equation. And then when you hit graph, if you don't see what you want to see, the buttons you want to use are zoom 6, which will make a standard zoom, which will zoom in or out to a standard amount. Or possibly zoom 0 is another good one. Zoom 0 is called zoom fit. And that tells the calculator, hey, you decide how I should look at this graph. And here's my zoom 0. You can see, hopefully, you can see that my graph is shown. You can see it's exponential. But the important thing isn't even the graph here. I get an idea of what it looks like. But the important thing here is the table. So we're going to go to second table. When you graph, it's usually easier to have integer coordinates. So let's just scroll through the table here until we find some values we can use. Like for instance, 2, 7. So I want to make 2, 7. 3, 3. Make 3, 3. 4, 1. 5, 0. And let's see if we can find any more integers. Nope. After that, oh, there we go. Negative 16, 1. Now, that's not actually negative 1. If I hover over it, I'll see that it's 0.99995. So it says plot at least 4 points. I've plotted 4 points. That should be enough. Let's hit done. And now it wants us to draw. So when I scroll through my table and I scroll down, you can see that my y1 is getting closer and closer and closer to negative 1, but it says that it hits it. But if you hover over those numbers, they're still negative 0.999 something. So this line here, this negative 1, is called an asymptote. That means that the graph approaches that value, but it never actually hits it. So we want to make sure that our graph never actually hits the negative 1, but comes pretty close to it. And I'm going to do my best with my mouse here to draw. Not great. Let's see if it allows that as my answer. Yeah, it didn't like it. That's what it should look like. If I was a better drawer, that's what it would look like. Okay. Next section. Same thing. Use technology to find the points. Now we're graphing a log function. So we're going to go to y equals, and we're going to type in. Remember to get to that log with the downwriting. That's called log base, and you get there by doing math and then scroll down to log base, which is letter A. So math and scroll down to log base 2, x plus 5 plus 3. When you graph logs or when you graph exponential graphs, you're going to have that thing that I said earlier, an asymptote. And that means you're going to have a line parallel to the x-axis or a line parallel to the y-axis that our graph approaches, but it never hits. So when I graph this, I'm going to use zoom 6. And I end up getting my graph on my screen. Remember, the graph is okay, but we really need the table. So we'll go to second table and scroll through. Let's find some values that we can actually use here. Like, for instance, 3, negative 3, negative 1, negative 1, negative 3, positive 1, negative 4, 3, and then everything above that is an error, so that's good. So it looks like anything beyond negative 4 to the left of negative 4 is an error. So that's because the equation has an x plus 5, and if we were to put a negative 5 in there, we'd get a 0, and you can't have a log. You can't take a log of 0. So we're going to make this graph get as close to negative 5 as we can. without hitting it. And I may hit it there. Actually, I'll pass it there, but I'm doing my best with my mouse here. And then same here. When I scroll down, it looks like my graph is going to go closer to... It's going to keep going down. So there's no asymptote here, so we can go down as far as we need to. Let's see if I did better on this one. Yeah, that's what it should have looked like. My drawing was not great up here, and then down here wasn't great either. So just do a better job than I did at your drawings. All right, this one just wants us to graph again, but this time it's going to ask us for the asymptote. So I go to math, I go to log base 5x plus 4. To find the asymptote, the easiest way, without getting into pre-calc and calc stuff, the easiest thing you can do is just scroll through the table and see if there's a value that it looks like it's getting closer and closer to and never hitting. And in this case, our asymptote looks like it's going to be negative. It's going to be 0, right? Because right here, I'd be logging a 0. So our asymptote's going to be a vertical asymptote at 0. So see the red line here? And if I hit graph, you can see we have a way to make a vertical asymptote. Now we just got to move those yellow dots. Let's move those yellow dots to some values like 1, 4 would be a good one. And 5, 5 would be a good one. So 5, 5. So you can see the graph does what it does on my calculator screen. And this dotted line, I put it on top of in this case, the y-axis. That's because when I hit graph on my screen, the graph just stops there. And when I go to the table, I get a bunch of errors for anything 0 or less. Got that one right. Finally got one right. And then the last one is just going to ask you features about the graph. So let's do this one together. What are the features of this graph? The function is an logarithmic graph because it has the word log in it. It has a horizontal, no, it has a vertical asymptote. You can see the graph gets closer and closer to the y-axis. And the y-axis's equation is x equals 0. The range of the function, range is the y value. What's the lowest and the highest value that this graph ever goes to? So this graph goes down forever on the y-axis. And it looks like it goes up forever. We can graph it to confirm, but I think it goes up and down forever. No, that's not a choice. Oh, there it is right there. Low forever, high forever. Is it increasing or decreasing? Well, it's increasing because when we read a graph left to right, it's going uphill. What's the domain? Domain is the x value. What's the lowest x value we'll ever have here? 0. What's the highest x value we'll ever have here? Infinity. The end behavior. End behavior means what does it do at the ends, at the arrows? So on the left side, it approaches negative infinity. Oh, but it only approaches 0. Anything beyond 0, it doesn't even ever get to. So it approaches an x of 0. And when it gets there, the y values are getting smaller. And on the right side, it can go forever, and the y values will go up forever. So I know that was a lot here. I'll go through one more time here. It's a logarithmic graph. A vertical asymptote means that the graph up and down has a line that it's following but not hitting. X equals 0 is the equation for this asymptote because it's the y-axis. The range is the lowest and the highest y value. This graph goes down forever and it goes up forever. So it has a range of infinity, negative infinity to positive infinity. It's increasing because when you read it left to right, it's going uphill. The domain is the x values, and the lowest x value we ever use is 0, and the highest x value we ever use is infinity. End behavior talks about the arrows. the left arrow approaches 0 on the x-axis. And when it does that, the y approaches negative infinity. And the right arrow approaches infinity. As our x-axis is going to get higher and higher. It's never going to stop. And our y is also going to get higher and higher. So that should all be correct. All right, so that's features of graphing exponential and log functions. Thanks for watching today. Have a good day.